This video is on the objective: complete the steps of a two-mean hypothesis test with population standard deviations, SDs, known. And this is the critical value approach. Alright, so this is the second video on this objective. Hopefully you saw the first one. I'm going to be going through the exact same steps here, only, we'll see if it changes from a left-tailed test to a right-tailed. The first video was a left-tailed test. This might be a different kind of test. We'll see. Alright, so again, if you want to see more about it, this objective, click on More Instruction and look at their videos, their notes, their examples. Hopefully those help you. Alright, so Mrs. Tilley's freshman algebra classes always complete an end-of-the-year exam. Last year, 72 randomly selected students completed the exam and averaged a score of 68, with a known standard deviation of 11.7. So this was the standard deviation, of all her last year classes, algebra classes. So this is the population standard deviation from the last year classes. She decided to change her teaching style this year and then compare the end results. At the end of the most current year, 64 randomly selected students completed the exam with an average of 75. And again, the known standard deviation. So this is a standard deviation for the population that's given to us here. Let's call it sigma 2. Is 12.4. And the sample sizes are large enough. You had 72, 64. They're sufficiently large. They're randomly taken. Right, that's another condition. We know the population standard deviations. Okay. And they should be independent of one another, right? The students from last year should be different than the students from this year. So the results of last year should be independent of the results from this year. So all the conditions are met to where we can run this difference between two means test with population standard deviations known. Alright, so the question is there enough evidence at a 1% significance level, right? Alpha is 0.01, to show that there is a difference in the mean scores from last year to this year. Okay. Alright, so I'm going to go to a piece of paper and we'll just start writing out all the steps. Right? All the steps you run through for any hypothesis test. Right? You've seen me do plenty of hypothesis testing by now, hopefully. So I'm going to say what these things mean. Alright, so let's say mu1 is the population, the average score for all of last year's students. Alright, let's say all of last year's students. And say mu2 is the average score on this final exam for this year's, the current year's students. Now what we're testing here, right? There's a claim, a belief, or something to be tested. What we're asked to test here at the 1% significance level is that there is a difference in these mean scores, right? The mean scores from last year to this year. So the claim here, what we're testing is that mu1 is different than mu2. There is a difference between them. They're not the same. Another way to state this in terms of the difference between the means would be that mu1 minus mu2 is not 0. Okay. Alright, and once the claim is established, right, then you can set up your hypotheses. Now this does not involve equality, this claim. Right, it's not equal, so that'll be represented by the alternative hypothesis. Right, that mu1 minus mu2 is not 0, right, that these averages are different. And the opposite of this will be the null, that mu1 minus mu2 is equal to 0. And this is what we're going to be assuming. And then later on decide if we like this or not. Are we going to reject this assumption or not based on the sample evidence? So we're going to assume that these averages are equal, right? That there was no change in the average from last year to this year. And the alternate is again the claim that there is a change, that there is some sort of difference. Now, looking at the alternate also tells you what kind of a test is being run, right? This is the parameter is not equal to some value. So this is a two-tailed test. Two-tailed test, meaning when I set up, find my critical values and set up rejection regions, right? There's two of them, one on the left tail, one on the right tail. And each of those tails will have an area of half of alpha. Now alpha was given as 1%, right? The significance level for this test we're asked to perform is 1%. All right, now let's look at the sample information. Let's look at the sample information. Let's look. You had information about some last year exams, and from this year as well, the current year. Now the size, she took 72 students randomly from last year, found that their average score was 68. And this is a separate thing, but it's related to last year's students. She says she knows that the standard deviation for all of the entire population of last year's students was 11.7. Right, so sigma 1, 11.7. This year's students, right? She took a sample of 64 randomly selected students. That's N2. The average score x2 bar for these 64 students was 75. And again, this is a separate thing. This isn't for the sample. This is for the population. She claims to know. She says she knows the standard deviation for the entire population of this year's students. So sigma 2 is 12.4. Right. And then using this sample information, we calculate our test statistic. Remember, since the population standard deviations are known, when I look at the difference of sample means, x1 bars minus x2 bars, the distribution of those differences will be a normal distribution, right? Not a student's t distribution. And so when I calculate the test statistic, it's going to be a z-score. And that z-score was, what is the difference in our sample means, right? x1 bar minus x2 bar minus the assumed difference. Remember, we're assuming that the difference between population means here is 0. So you could say minus 0 if you want, but there's no need to write that. And then how many standard deviations is that, right? That's what the z-score was. And the standard deviation for the difference in sample means was this thing here. It was the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. And make sure all of that is underneath your square root symbol. All right, so I'm going to enter this stuff in. We're going to have in the numerator 68 x1 bar minus 75, and then divided by this standard error for the difference in sample means distribution, the square root of 11.7 squared divided by 672 plus, and then 12.4 squared divided by 64. All right, and again, I'm going to enter this into a calculator and maybe round it to 2 decimal places or something. Well, you know what? Let me get back. I'll enter this, but then I'm going to go back to the assignment and we'll get to this point. All right. So now the numerator, now 68 minus 75, that's just negative 7. All right, so I'm going to put negative 7 in the numerator, divided by, and then the square root of, and just make sure all this is underneath the square root symbol, 11.7 squared divided by 72 plus 12.4 squared divided by 64. Okay, and then we've got, all right, so we're getting approximately negative 3.37 if I round to 2 decimal places for the test statistic. All right, so I'm kind of getting ahead of myself here. Let's go back to the assignment. Now, the first thing they want is what is the null hypothesis and the alternative. Now, the null will just be that, mu1 equals mu2. And as I said earlier, this is where is the not equals? This should be under comparison stuff here. Yeah, there it is. All right. So mu1 is not equal to mu2, right? That there is a difference. So there are the null and alternative hypotheses. And then I'm sure we'll get the next step is to give us the test statistic and stuff like that. Alright, so they're having us do the critical values. Alright. Again, there should be more than one. Alright, there should be 2 critical values. This is a 2-tailed test. And I wonder if it doesn't say use the plus or minus symbol, right? Because there should be one positive, one negative. It just says list them all. So maybe I should separate them by a comma. I'm gonna use the plus or minus symbol and see what happens. But let's go back to my paper. So I've calculated the test statistic, which I'm sure they're going to ask us to do in a second. But this for our sample means, the difference in our sample means, the z-score was negative 3.37. And now we get into the critical values and rejection regions. Right? Let's say critical values. Okay, so we're looking at the z-scores, right? So the standard normal distribution, the z distribution. So my number line here represents z-scores, and got a symmetrical bell-shaped curve above that. The z-score underneath the peak, it is a z-score of 0. Now, we're looking for the following. Right, again, it's a 2-tailed test. Right? I said that earlier. It's a 2-tailed test. And alpha is 1%. Remember, alpha should be the total area of both rejection regions put together. So I got a right tail rejection region, and one on the same distance on the other side. It's symmetrical. A left tail rejection region. And the area of each of these should be 0.5%, right? 0.005. Same thing over here. The area of this left tail rejection region should be 0.5%. That way, when you add them up, you get alpha. You get 1%. So what I'm looking for is what is the z-score with 0.5% above it, and its opposite. Right? What's the opposite z-score with 0.5% below it? And these are found from my little table. Right? So if you look at this table here, the z-score with 0.5% above it, 0.005, is 2.576. So these critical values are positive 2.576, and the one over here for the left tail, negative 2.576. All right. So I'll enter that. All right. So back here, critical value. Now it says put both. Now again, I'm hoping this works. I'll do the plus or minus, right, because there's one positive, one negative, and then 2.576. Alright, so it wants them separately. Okay, so it says here if there's more than one, please list them all. Alright, so here's what I'm going to do. Get rid of the plus or minus. Okay, get rid of the plus or minus, and then put positive 2.576, comma, negative 2.576. All right. and list them separately like that. Yeah, so it looks like that's how they want it. So they didn't mention using the plus or minus symbol, so don't. All right, I guess that's the lesson to take from this. All right, and then now that I've got the critical values, they're going to ask us, what's the test statistic? Now I already calculated that. All right, that was, usually I do that. You should do that before you set up your regions, but it doesn't really matter what order, I guess. I said it was negative 3.37. All right, rounded to the nearest hundredth, 2 decimal places. So negative 3.37. And again, they'll show you the calculation that I went through with that z-score. Same calculation I showed you earlier. And then I'm sure finally they're going to have us make a conclusion now. Right? Do you reject the null? Do you not reject the null? Or fail to reject it? And then what is the conclusion? Related to the claim. So I'm going back to my paper. Now. Get rid of the calculator. So now that I've got the critical values set up, the rejection regions, this two-tailed test here, our test statistic came at, back at negative 3.37. That's over here on the number line. Right? Negative 3.37. Definitely to the left of negative 2.576, right? The entrance to this rejection region. So the test statistic is in a rejection region. So I'm going to reject the null hypothesis. Now, what was the null hypothesis again? The null hypothesis was the statement that the averages were equal, that the average from last year and the average from this year were the same. So we're rejecting this null hypothesis, meaning that we're accepting the other statement, right, the alternative. And this was the claim, right? The claim was the alternative hypothesis, that the average from last year and the average from this year are different. So that's what I end up stating. We rejected the null hypothesis, therefore we're going to support the alternative hypothesis, which was the claim. I would say that there's enough evidence in these samples to support that claim that there is a difference between the averages from last year and the average from this year. Okay, so reading through these, again, it's one of these two. Let's see, reject the null hypothesis. There is strong evidence to show that there is a difference in the mean scores from last. Yes, that's exactly what I just said. There is evidence to support the claim, to say that there is a difference in the mean scores from last year to this year. Right, so that third option would be my conclusion. And again, please read through your answer explanations. Alright, so hopefully watching me go through the steps, and again, you've seen these steps plenty of times now, but hopefully watching me go through this, looking at the more instruction if you need to, reading the answer explanations when they come up. Hopefully all this stuff helps you out when you're working on this on your own. And thanks for watching.